fire protection, an accelerant is any substance or mixtures that accelerate or speed the development and escalating of fire. Accelerants are often used to combat arson, and some accelerant may cause an explosion. Some fire investigators use the term accelerant to mean any substance that initiate or promote a fire without implying intent or malice. The application of forensic science to fire and arson investigation often refers to chemical and other laboratory tests of materials recovered from the fire scene. Most frequently, investigators submit samples of debris from the fire scene that they believe may have been set to determine if any accelerant may have been used. To identify the presence of accelerant in the fire debris sample, the analytical techniques such as FTIR or GCML will be conducted. But before the analytical technique being done, sample preparation, which is the extraction method, will be conducted to separate the compound from the fire debris. The current method used to adsorption from the fire debris samples is using passive adsorption method, where this method involves concentrating vapor from the headspace of a sample within the closed system onto a suitable adsorbent, then dissolve the recovered species. The commonly adsorbent used in the passive adsorption is activated charcoal, or also known as activated carbon, which then will dissolve their solvent carbon disulfide. Other adsorption method, which is the modern technique, is using solid phase microextraction and use adsorbents such as TNXTA, which dissolve thermally. Activated charcoal is functional group materials that has characteristics such as large surface area, strong adsorption capacity, stable physical and chemical properties, and also renewable. Since it has a characteristic of strong adsorption capacity, it has been used as adsorbent to absorb various volatile organic compounds in fire case along with passive headspace extraction. The absorption occurs as the solvent is held on the surface and in the pores of the activated charcoal by the van der Waals force of extraction. The solvent then can be easily dissolved by heating the activated charcoals. Since most of the sample preparation use activated charcoal strip as the adsorbent to absorb the accelerant residues on the fire debris sample, another alternative is by replacing the activated charcoal with zeolite. Zeolite has almost the same properties as activated charcoal. Zeolite are three-dimensional, microporous, inorganic crystalline solid with well-defined structures which contain aluminium, silicon, and oxygen in their regular framework. Many researchers have proved that zeolite has good absorption characteristics which has potentially to be used as adsorbent. The unusual crystalline structures give the zeolite a unique chemical properties. The natural zeolite are naturally formed from the ash of volcanoes that mix up with the ocean water. Zeolite have many types, and each type of natural zeolite have different crystal structures and chemical composition. The different properties of zeolite will having different application, and the major application areas of zeolite are as ion exchangers and adsorbent. The ratio of silica to alumina in zeolite structures, pores volume and size, types of adsorption site, acidity properties, chemical composition, shape of cage, and channel in zeolite structures are factors which contribute to variation of zeolite adsorption properties. The aluminum in zeolite regulates the polar properties of zeolite, in which will produce strong interaction with polar molecule. The silica in the zeolite will make the zeolite hydrophilic or hydrophobic properties. These hydrophilic and hydrophobic properties can influence the activity of adsorption and catalytic process. The advantages of zeolite is that it's stable either in acidic media or alkaline environment, and high humidity condition will not affect their adsorption properties. The stability of zeolite properties make it crucial to their application as ion exchangers, sorbent, and catalysts. In addition, zeolite are reusable material as can be regenerated by using heating method to remove the adsorbed materials. Zeolite is non-toxic materials when exposed to it, which make it safe material to be used, and it is environmental friendly. A good absorbent must have properties as high adsorption capacity, high selectivity, good mechanical strength, high stability adsorption capacity, and adequate adsorption-desorption kinetic, which all these properties are present in zeolite.